In impulse momentum theorem, we can apply this particular principle. We can apply this principle in collisions. So what do we mean by collision? Ano ibig sabihin ng collision? Siyempre, when two objects are in contact with each other, they are in contact because of a certain force applied to them. They are colliding. So one good example of a collision is what? Banggaan ng kotse. Diba? What happens? Kapag nagbanggaan yung dalawang kotse, ano nangyari? May mga kotse na matibay, hindi lang siya. Right? Sige. Zydrix, ano nangyayari kapag nagbabanggaan yung kotse?
Since po, sir, kapag magpanggap po ng kotse, sir, since may force po man, dahil po din sa speed, so ang mangyayari po, sir, magkakaroon po ng force yung parang masisira po yung kotse at saka possible po, sir, magkaroon po ng aksidente ng driver po, sir.
Okay. So, may tendencies na yung mga tao sa loob ng kotse ay natitilapon. Diba? May impact, since there's an impact because of the force present in the object, and nagbanggaan yung dalawang kotse na both of them has forces present and they are moving at relative speeds. Okay, they are relative with each other. Ano na nangyayari is, mayroon dumidikit, mayroon tumitilapon. Right? Another example is the marble. Diba? Yung mga bata pa tayo, or baka ngayon, naglalaro pa rin kayo ng marbles, or minsan nakikita ko kayo naman sa field, naglalaro ng marbles. Diba? Or billiards. Diba? Sa billiards, what happens in the billiard when a cue ball hits a billiard ball? Ano nangyayari? Yung cue ball ay minsan nag-stay sa position or pumupunta ng ibang direction. Right? Tapos yung ibang bola or billiards ay tumitilapon sa iba't ibang direction. So that's also an example of a collision. Right? When two objects are in contact with each other or colliding, moving against each other, that's what we call collision. Okay? It's a physical condition or it's a physical phenomenon where objects hit one another. And there are two types of collision. We have elastic and inelastic. Now, from the term itself, elastic, what do we mean by that? Anong ibig sabihin ng kapag elastic? Siyempre, elastic, ibig sabihin, stretchable. Right? Stretchable siya. Inelastic naman, ibig sabihin yan ay hindi siya stretchable. Okay? Hindi siya bumabalik sa pwesto niya. Ang elastic, bumabalik siya sa pwesto. Yung inelastic, hindi. But in the case of collision, paano natin masasabi or how can we identify or how can we prove that this particular object is elastic or experience elastic collision or inelastic collision? Now, in technical terms, if we're going to use the momentum and the energy of the system, when I talk system is the group of objects present, if the total momentum and the energy of the system are conserved after the collision, ibig sabihin, it is elastic. And if it's not conserved, okay, the total momentum is conserved but the kinetic energy of the object is not conserved, then we cannot consider this particular object to be in an inelastic collision. Now, graphically, how do we illustrate elastic and inelastic collision? Anyone, who can give me an example of elastic and inelastic collision? Yes, Anissa.
An example of elastic collision is when, like, pag may soccer player na sinipa niya ang bola, so parang hindi dumitikit ang paa sa bola kaya siya elastic kasi parang nag-bounce back. Well, ang inelastic collision, another example is yung comets or yung asteroids like mag-collide. Ganun. Yun lang. Thank you.
Very good. No? So, ibig sabihin, there is a separation, okay? In elastic collision, there is a separation of bodies. Okay? When I talk about body, bakit pa iba-iba ang term ng gamit ko? But I don't know kasi yan. When I talk about bodies, I pertain also to the object. So usually bodies, dependent, it has the same definition. Okay? So in elastic, there is, dumidikit, in elastic collision, hindi dumidikit yung mga bodies after colliding. Of course naman, of course, during collision, magkadikit talaga sila. The bodies or the objects ay magkadikit. Pero, if collision hindi na magkadikit, that's the time these particular objects are not inelastic. They are inelastic collision. Again, kapag hindi magkadikit yung bodies after collision, ibig sabihin yan, elastic. If magkadikit sila after collision pa rin, all the way, okay, ibig sabihin nun, nasa inelastic collision pa rin sila. Okay? So, let me show you a simulation on how elastic and inelastic collisions happen. Parallel. So of course, we're just talking all about translational but one-dimensional collision kasi magkaiba din naman kapag two-dimensional. Yung billiards kanina is an example of a two-dimensional. Let's focus only on one dimension. So I have here two objects. Object 1, is it clear? Klaro lang ba siya sa inyo or do I need to make it more, ano pa?
Okay na po, sir.
Okay na ba siya? Now, I have here object 1. If you can see, I'm pointing now at the blue ball. The object 1 has 0.5 kilograms and the object 2 is 1.5 kilograms. Now, let's try to see what happens when these two objects collide. So they are moving at different speeds. So what happened to ball number 1? What happened to ball number 1? Yes, Zydex.
Ano po, sir, in my own observations, sir, when you look at yung object number 2, since malaki po siya, sir, tapos yung object number 1 nagpunta po sa object number 2, ang nangyari po, po siya, sir, yung object number 1, since maliit po siya, nandun, napunta po siya backwards, and maybe because of the, po, sir, the size of the object number 2, ng rason kung bakit, dahil kung maliit po kasi maliit man po yung object number 1, tapos kapag, ayan na po, sir, yan, ano po, sir, dahil po dyan, yung mas mabigat po yung object number 2, so since in object number 1 mas light po, so that is why yung object number 1 nagpunta po backwards, maybe because of the size or the weight. So thank you.
Very good. That's correct. Because of the size of the mass of object number 1, it went after collision. It went to the opposite direction. Notice that this ball is moving towards the left, towards the right. After meeting both of them, okay? After meeting, both objects bounce towards different directions. But the speed the speed of these two objects are different. So let's try to inspect the speed. So let's place some values. So, of course, the heavier the object, the lesser the speed. So let's try to inspect. So each of them has its own momentum. So each of them has its own momentum. So let's try to see what happens when they are colliding with each other. So you focus on the speed. What happened to the speed of the object? Again, what happened to the speed? MI.
Sir, bale yung sa first ball, nag-increase yung speed niya. Tapos, nakita natin yung value, parang kalahati nung sa ball 2 na bawas. Bale, napunta siya sa ball 1.
So, the energy, okay, the speed increased in ball 1, right? After collision, it increased. And after, in ball number 2, it decreased. So of course, by definition, that there is a force acting on the object. No, this is still following the law of acceleration. Object 2, object 2 is giving out a force to object 1. So that object 1 will accelerate. In this case, object 1 is already accelerating because it changed its speed. Right? So what happened to object 2? It decreased. So bakit kaya? Okay, that's the question. Bakit kaya nag-decrease ang speed? So what is the implication of this? So let's try to see the energy present. What did you observe about the energy of this particular motion, of the collision? What happened to the energy? Again, I have here the energy. The kinetic energy is equal to 0.44 joules. So what happened to the energy after collision? If the velocity of mass 1, if the velocity of mass number 1 increased, then the velocity of mass number 2 decreased. But what happened to the velocity of the object? Or the kinetic energy, rather? Yes, Chelsea?
Nag-remain lang, sir, yung kinetic energy niya, sir, since it's still moving.
Since it's still moving, so ibig sabihin, in this collision, the energy is conserved. So ibig sabihin, the total energy of the system. So individually, okay, if we inspect individual objects' kinetic energy, there is really a change, right? Siyempre, from what's the initial velocity of this? 1 meter per second. So we expect what? What is the kinetic energy of ball number 1? So it's what? Is it higher than ball number 2? So it's, but we know that these two energies are different, right? It's different. But what we have observed in the simulator is that the kinetic energy of the system as a whole is just the same. But considering that both of them has different kinetic energies, how is that even possible? And we have observed also that ball number 1 increased its velocity. So if there is an increase in the velocity of the object, then there should be also an increase of the kinetic energy. So what happens? The kinetic energy in ball number 2 was decreased, but the kinetic energy in ball number 1 increased. So here comes the play of the conservation of energy. Right? And what is conservation of energy is telling us? Is that what? Energy is neither created nor destroyed. It can only be transformed from one to another. Okay? So, humina or bumaba ang kinetic energy ng mass 2 because humina ang galaw niya. And bakit humina ang galaw niya? Because ball number 2 exerted a force to ball number 1 that caused the acceleration of the object. Since ball number 1 is accelerating, then we expect that the kinetic energy of ball number 1 should be increasing. But if we take a closer look on the kinetic energy of the system, it's just the same. So when the momentum and the kinetic energy of the system is the same, then that's what we can consider as elastic collision. Now, later on, let's take a closer look on what really happens mathematically. Okay? Now, let's go if it's inelastic. Let's go if inelastic. Let's observe what happened. What happened? Ano nangyari? Sige, what happened?
Since inelastic po siya, sir, yung ano po, sir, yung object number 1, nagpunta po sa object number 2, ang nangyari, instead na yung object number 1 na doon na po sa left, nadikit po siya sa object number 2. So, yung sa object number 2, nagpunta po siya sa right. So, yung napansin niyo po, sir, yung object number 1 po, sir, nandyan pa po sa object number 2. Since inelastic, yan po. Yan po yung
Okay.
result.
Okay, thank you very much, Zaid. That's correct. Sa inelastic collision, both objects do not separate with each other. So, what is the resulting motion? What is the resulting movement of this particular collision? Whoever has the highest velocity, highest mass, who is more heavier, doon sasama yung mas mababang mass, yung mas lighter. Okay? Of course, the lighter mass will move towards the direction of the heavier mass. So that's inelastic collision. But what happened? What happened to the kinetic energy? So in the kinetic energy is 0.44 joules. Let's take a closer look after collision. Okay? What happened to the kinetic energy? The kinetic energy of the system decreased, right? It decreased. Bakit kaya, Gio, Giovanni, bakit kaya nag-decrease ang kinetic energy ng system? Any idea? Bakit nag-decrease ang kinetic energy ng system? Bakit kaya? Sige, Zydrates.
Maybe because po, sir, due to the force po, sir, tsaka yung ano po, sir, dahil po nga na mas malaki po yung object number 2, so yung kinetic energy po na decrease.
Bakit kaya? That's somehow close. Sige, Carl.
Dahil sir, bumaba yung velocity.
Bumaba ang velocity. Bumaba ba ang velocity nilang dalawa? Yes, no? Bumaba yung velocity nila. But what have you observed in the velocity of the two objects? Mike Owen.
Ano sir, nagbaba yung kinetic energy sa whole system sir kasi upon colliding nung dalawang objects sir, parang yung force na meron sa sa big ball parang nasama siya dun sa small. Tapos since magkadikit sila sir, parang nag-move sila as one, kaya mas nagmahina.
They are moving as one group. They are moving as a system. Okay? So if they are moving as a system, then the kinetic energy that we're considering is also a one system. Hindi na nga sila nag-separate. Okay? So since bumaba yung kanilang kinetic energy, and what caused the decrease of the kinetic energy is because Mr. Giovanni, bakit? Bakit bumaba yung kinetic energy nila after colliding? Because I can't see the chat. Kasi ewan ko, I don't know what happened. Sige. Giovanni. Why do you think nag-decrease? Because also, sige, baka na-check. Why do you think it decreased the kinetic energy of the system is also because if you notice the two velocities, they have the same velocity and it decreased from 1, is that 1? From 1 to 0.13. From 0.5, it decreased to 0.13. Now, let me share again my slide. So let's take a closer look mathematically. No? Let's use math. Let's use math. Let's use math on why. So in elastic collisions, the total momentum is observed. The total momentum is observed in before and after. So whatever will be the momentum before should be the same after. But in elastic, it should also be the same. This one is inelastic. What I have shown you a while ago is perfectly inelastic. Iba din kasi ang perfectly inelastic. Ibig sabihin ng perfectly inelastic, yung magkadikit talaga sila. So what we have shown a while ago or nakita natin kanina sa simulator is an example of a perfectly inelastic. So in the perfectly inelastic collision, what happened after collision? Two separate momentum, two separate kinetic energies. After collision, they have the same momentum after colliding with each other, hence having the same kinetic energy all throughout because they have the same velocity after colliding with each other. Now, in inelastic collisions, let's say for example, it is not perfectly inelastic, so may part na magkahiwalay sila pero they are going in the same direction. We also consider that one using the descriptions we have in elastic collision. So in elastic collision, we have the first momentum of the object, the second momentum of the object, the final momentum of the first object, and the final momentum of the second object. Now, we have said that these two momentums, or the two momenta, plural, the two momenta of the system should be the same with each other after collision. So whatever will be the momentum before the collision should be the same after the collision. if we are talking about elastic collision. And of course, we have observed a while ago that there's changes in the velocity because of the change in the kinetic energy of an individual object. And if we get the ratio between the speeds, okay, between the speed of the system after and before the collision, we have the so-called coefficient of restitution. So that's defined as E is equal to the speed after collision all over the speed before the collision. Now, I have here an example so that answers your problem number 1 or the clarifying understanding. So if there are two objects moving, find the velocity after collision, and according to the problem, it is perfectly inelastic. So that's what happened here is that we just substitute all of the variables that we know and treat it as a vector quantity. Okay, let's treat everything as a vector quantity. So we want to know what is the velocity after collision, and that's equal to negative 3 meters per second. Why negative? Because we're moving to the left. Okay? We are moving towards the left. So the kinetic energy can be also the kinetic energy, individual kinetic energy, and total kinetic energy can be determined by expecting or inspecting the individual kinetic energies of the object. So if they are moving at particular speeds, then they can also move at this certain speed. Okay, so they have the particular kinetic energies, and the total kinetic energy is equal to 177 or 178 joules. So after collision, so sabi natin, there is a decrease of kinetic energy because there is a decrease in the object's in the object's velocity that's equal to 40 joules. So how much kinetic energy was lost is equal to 138 joules. So final minus before minus initial. Questions? Questions? Yes, Emma.
Sir, paano namin malalaman kung alin sa yung object na may velocity papunta sa left?
Paano nyo malalaman kung papunta ba siya sa left or sa right? Okay. Usually, tama ba ganun ba, Emma, no?
Sir, parang paano malaman alin sa kanila ang papunta sa left or papunta sa right?
Paano sa kanila? Okay, in this problem, it wasn't stated, right? Hindi siya stated kung sino papunta sa left, sino papunta sa right. Tama? So what we did here, but we know that both of them are moving in opposite directions. Yes? Sinabi sa problem, di ba? We know that these two objects are moving in opposite directions. So we need to assume, and we need to assign someone who is moving to the left, who is moving to the right. So ganun lang. It's based on our assumption. Yes.
Sir, what if pag yung first object yung papunta sa left, pwede din sir, same lang ang answer.
If yung isa going sa left, pero yung isa going sa right. Ganun ba? Or both of them are going to the left?
Bale, magiging velocity, yung negative velocity sir is yung 4.5.
Pwede naman din. Pwede naman din siyang ganun.
Mag-change siya sir. Same lang or mag-change.
Itong negative 4.5, no? Itong negative 4, ito 4.5 ay magiging negative. Tapos itong 7.2 magiging positive. I think magiging same lang naman din yan siya. Yeah, same lang siya. Okay, this is 40, minus negative 14, that's still the same. I think that will still give you 25. So hindi na siya negative 3. 25, negative, positive 3 na lang siya. That's still.
Thank you, sir.
You're welcome.